If you watched the previous episode, you'll know that we are trying to bring back into service this 1954 Marconi Mk3 camera. It's just 10 days until the 2026 Retrotech exhibition, and its 72-year-old electronics are still being coaxed back into life.
During this testing phase, the run-up procedure is more complicated and involving the variac at half mains, but we'll come to that in a moment. The first thing to check is that the beam current control for the tube is at 0. This control here, I've checked it and it is at 0. This protects the tube from any potential damage due to scan failure or whatnot. And I like to start it at half mains, thus, and turn the variac output on. And that's now on. I've left the switch in the on position. Interestingly, I can do that. That's off, on. Marconi wired them upside down, just to be difficult in the American style. So we're going to let that cook for a few minutes, and then I'll turn the mains voltage up a bit more. And the idea behind this is that it gives all the transformers in it, the mains transformers, a bit of warming up to make sure they're free of damp. So we'll let that cook for a bit. Now we've been running at half mains for a while, and because the valve rectifiers are emitting, there is some HT voltage. The meter here is on a ×2 arrangement, so that's about 180 volts or so output, and this has exercised things a bit. There is an argument that says you shouldn't run valve heaters at a low voltage, but we're only running them at a low voltage for a bit, and there is a degree of swings and roundabouts in this. Going back to the meter, that's measuring the voltage, and by rotating it round we can measure the currents in the individual stabiliser valves, and they all should be sort of much the same, except for that one. That's the focus current, which comes from a separate unit, so it can't be measured in with this switch, and that's the total current and the voltage. So we're going back to the variac now, and I'm going to wind this up to 220, well, maybe 230. Let's give it some wallop. And we're drawing just shy of 6 amps. Back to the meter. In this case, this meter here, and you can see that the pointer is over the green bit, and it's arranged so that when the mains voltage is correct, the needle falls into the green bit. And as this is a outside broadcast power supply with its wavy mains, this switch adjusts the taps on the primary of the mains transformer to give the suitable reading. There are 6 rectifier valves and 6 double triode stabiliser valves. It all gets quite hot in there, and you can hear a whirring noise. That's from the fan. Down there's a fan, and it draws its air, and I find this really unusual. It draws its air through this box, and in the box is the mains transformer, and it's an air-cooled mains transformer, especially designed so that the passage of air through the rather loose windings takes away the heat. The output of the fan blows into this box with all the sweaty rectifiers. The rack mount version of this power supply has got an absolutely enormous transformer relying on normal convection cooling. Anyway, enough about that. So we've got the correct mains voltage going in. The DC voltage from the output of the power supply is where I would expect it to be, at 250. That's 250 DC stabilised at about an amp. There's an additional unstabilised output of 330 volts, which is used for various scan circuits and the like. I can see here we've got a line on the waveform monitor, and if I turn that on, it's the SPG I've just turned on. a raster springs into life. It's a bit on the bright side, and we have a trace on the waveform monitor. And again, at this point I'm going to leave it to settle down. Everything has to get up to sort of operating temperature before you can make any realistic adjustments. So I'm turning the picture brightness down and the waveform brightness down to save tube life, and also the brightness on the viewfinder back here. Poke your camera down there. That's the raster on the viewfinder tube, and there's a piece of glass there, magnifying glass, which helps those of us to see. So that's the brightness going down, and when you come back to it, you need to remember that you've turned the brightness down. It's not bossed, the brightness is down. So we're going to let it all warm up, and we'll go to part 2 in a moment. Whilst we're looking at things, it's a convenient point to have a look at the focusing arrangements for the camera tube. Here is the scanning yoke for the camera tube. This is a 4.5-inch image orphan yoke containing the tube inside. The photocathode is at this end, the target here, the electron gun back here, and the scanning arrangements in the middle, and about here is the photomultiplier. There is a description of the tube and some information on TV Camera Museum website. If you go and look at that and poke around, you'll find tubes. So the focusing arrangement, the camera actually moves the tube to and fro rather than the more normal focusing arrangement on the lens. So that's in one position, and then you can see it trundling forward on this rather nice carriage arrangement. A nice smooth action from one end to the other. And the focusing control here, commonly called a beer handle at the time, comes off for transport and can be easily replaced, and you can set what position you like in it. So if you're using that range, it's convenient, or you could change it to there for a different range. The focusing mechanism. As part of the warming up process, apart from all the valves and the components related to them getting to a working temperature so that they finish drifting, there is the tube to consider. The image orphan tube has to reach its operating temperature as well, and it clearly states in the paperwork for it that the temperature must not exceed 50 degrees centigrade or fall below 35 degrees centigrade, a recommended temperature being 40. And in the yoke here there is a heating element to achieve that, and there's a thermistor and a valve feedback circuit so that when that temperature is achieved the heating stops, and there's an indicator here to tell you what the state of play is. So ideally that ought to go out, but that might take a while. The thing is warming up reasonably well, and I can feel it warm with my fingers, so we're going to turn the beam up now and adjust for a good picture. So back to the CCU. Do you remember how I turned the brightness down? Well, we're turning them back up, and the waveform is off to one side, and put it back in the middle. No doubt it will drift off again. So the black level is a bit high, so we'll have that down a bit, and I'm adjusting the line shading for a flat waveform. Now, having adjusted the waveform, the picture monitor and the waveform monitor to produce a raster, the black level is good, and I'm going to advance the beam control. And as I turn it up, you'll see a characteristic flare of the picture. Thus, do you see that? and that's overcooking it, and that's back down to just discharging. Now the next thing we need to do is make sure there's some light falling on the tube. I did optically cap the tube with the filter wheel control here, so I'll turn that round to 0, and that should let some light in. And black level down a bit. And I'm going to wave my hand in front of the lens now. So we're getting there. The next step is to optically focus the test card onto the tube. So I'm going to turn the camera, and over there you can just see the test card in the distance, propped up on my scope. Viewfinder brightness up. I'm just putting a bit of line shading in the sawtooth. As the viewfinder is flashing and banging for all it's worth, step one is to hit it. That settled it down a bit, but still no picture. Contrast. Why no picture? We had this before, and it turned out to be a dirty contact on the camera cable connector. So I'm just going to give that a wriggle. I can't reach it and see the picture at the same time.
No, we don't have a picture on the... Oh, we do have a very out of focus.
Yes, but I'm looking at the sawtooth.
Ah, okay.
Which is why I added it in, as it... The viewfinder picture leaves a lot to be desired. I had this problem earlier with a dirty contact on the camera cable, and you saw I gave it a wriggle and a bit of a reseat, and that helped a bit, but the viewfinder picture is not particularly usable. But I am seeing a picture on there, so I'll use that to focus with. Do a bit of centering. I'm going to lock the camera off. And I've now got a poor picture, so let's see if we can optimise that a bit. Just enough beam current to discharge it. Image focus, multi-focus, beam focus. That has improved the resolution somewhat. And I'm just going through optical focus there. All these things interact. There's optical focus, beam focus, image focus, and they all have an effect. You'll also see that our picture is somewhat oval. This may be a function of the display monitor, but I rather suspect it's a function of the tube, as that raster patch is more or less the right shape.
Now for the RetroTech event we wanted to run the camera on 405 lines. So naturally we liberated the recently restored sync pulse generator from MCR21. You might just be able to hear the 10 kHz line scan frequency on the following shots.
Well, you've got a picture. Now, having twiddled everything in sight, as you do, we've now got effectively three pictures: the viewfinder, the PWM and this Pi monitor down here. You have to ask yourself which one you believe. So my next step will be to set the actual raster size to 4:3 and then adjust the picture size to be so that the circles is round within that known raster. Otherwise you don't know what to believe. I'm not convinced the field waveform is right. Thinking, crunch crunch, gears running.
So we're running in 405 lines now, and we've got a very good picture, haven't we?
We're optimising it. Looking at the focus, where image orphan tubes have lots of focus knobs. Just about see 400 lines there with a bit of care. That flickeriness at the bottom of the picture annoys me. The thing is, it's also visible on this independent monitor here, which is currently overscanning in the line direction, because it was previously running on 625 and it's now on 405. There's the width knob. That's a bit more plausible. And I can see 400 lines resolution there on this monitor. It's amazing when you switch to 405 lines, you can actually see the lines where they on 625 they are imperceptible, which reminds me of a 405 technique they used to use called spot wobble, where you fitted an additional oscillator to your monitor or TV and it sort of jiggled the lines up and down like that to thicken them so that the gaps between them became imperceptible. Desperate times. Whilst I'm reasonably happy to poke around in the back of this CCU and most valve circuitry, it's because I'm trained and understand exactly what's happening. If you're not skilled in this area, you should not go anywhere near it, as you could end up rather like that open circuit resistor dead on the floor. So before we actually turn the camera on to a functioning state, I'd like to have a look at the mains input voltage. Although notionally we're plugged into a 13 amp socket, there is a bit of load about the place and I have noticed that the voltage is down. So on the power supply here is the meter, and you can see that the pointer is not hitting the green bit as it should. And this switch here adjusts the taps on the mains transformer, and I'll give it a click forward and that's popped it back in the green, which is where it should be. So now we're going to have a go at getting a picture. Much knob twiddling and hands on and going First thing is, I'm not sure how well you can see the waveform here, but I've just lifted the black level and you can see that the line sawtooth is showing, so we'll flatten that and a bit more lift. And the next thing to adjust is the beam current here, which I habitually leave it fully turned down to save any potential damage to the tube. So as I advance it, you should see as the tube starts to conduct, and hopefully we might get a bit of a picture, or at least the lift. Wrong knob. Wrong knob. This knob. There we go. That's quite a vigorous lift, so the black level needs to come down. And we've just got a plain white raster. And the next thing I want to adjust is I noticed that the black level was fully down. So here is the black level course. I'll pop that back in the middle and I'll just turn that down a bit so to give a better range of control. So the next step is to have a look at the camera and see if we've got the hope of an optical image. So the filter's open and light will be hitting the tube, so we might be able to get some sort of a picture. Let's go back to the CCU.
All the components are on the top surface and the valves are poking downwards underneath. There's just a few minor controls on the wiring area, but there's lots of scope for poking at components and getting an electric shock.
So they look to be as I would expect, so we're going to go back and see if the optical focus is plausible. Although we've got a white splat, it might be completely out of focus. Well, I've now got a picture on the viewfinder, so we'll go back to the CCU and continue tweaking. It's not much of a test card, but we'll put a test card up shortly. So that's the beam control, and just enough to discharge the picture.
At that time it was the custom for it to be all in one unit.
And it's a case of optimizing
Now, where to start? Well, that's the CRT housing, and here is the line scanner.
That's sort of optimized. There's this dark area across the top here.
Vignetting,
Yes.
What's causing that? Are we looking at the edge of the tube there?
I don't think so, but the only way to be certain about that is to adjust the centering on the camera and see if we can see the edges.